Welcome back to my channel, Trash to Teach.
Ethical AI Episode 3: Building Ethical Models, Data and Design. We've talked about the problems with biased AI, and we've defined what responsible AI looks like. Now it's time to build one. Today we're going from theory to practice. I'll show you exactly how to source ethical data and design algorithms with fairness built in from day one. We'll work through a real example, write actual code, and by the end, you'll have a template you can adapt for your own projects. Let's build something real, a resume screening AI for tech jobs. I've built a realistic resume screening AI that demonstrates the exact biases you'd see in production systems. Try screening for different positions and notice how the AI makes decisions. What makes this realistic and problematic? Prestige bias. The AI gives massive bonus points for prestigious schools, penalizing equally qualified candidates from community colleges or boot camps. Experience bias. It heavily weights years of experience over actual demonstrated skills, hurting career changers and new graduates. Company bias. Big tech company names get automatic bonuses, regardless of the candidate's actual contributions. Education pathway discrimination. Self-taught and boot camp graduates are systematically penalized. The scary part? This mirrors how many real screening systems work. They optimize for easily measurable proxies, school names, years of experience, company brands, rather than actual ability to do the job. Look at how Jordan Smith, self-taught, 2 years experience, strong portfolio, gets ranked lower than someone with less relevant skills but a prestigious background. That's algorithmic bias in action. What's your take on the results? Which candidate would you actually want to interview, and how does that compare to the AI's rankings? Where AI could actually help, consistency. At least it applies the same flawed criteria to everyone. Transparency. We can audit and see exactly why it made each decision. Speed. Definitely faster than human screening. Skill-focused evaluation. Could be redesigned to evaluate actual code samples, portfolio quality, problem-solving ability. But remember Amazon's hiring AI that discriminated against women? We're going to build one that doesn't make those mistakes. Here's our challenge. Create a system that identifies qualified candidates while ensuring fairness across gender, race, and other protected characteristics. Step 1. Ethical data sourcing. First rule of ethical AI, garbage in, garbage out. Your model is only as fair as your training data. Here's what most people do wrong. They grab historical hiring data and train on that. But if your company historically hired mostly men, your AI will learn that men are better candidates. So step 1, audit your data. We need to ask hard questions. Who is represented in this data? What time periods does it cover? What positions and companies? Are there gaps in representation that could skew results? Let me show you how to do this audit in code. We'll use Python with pandas and matplotlib. Already we can see problems. If historical hiring rates differ significantly by gender, that bias will get baked into our model. So how do we fix this? Option 1, collect more diverse data. Partner with organizations serving underrepresented groups. Actively recruit diverse resume samples. Option 2, synthetic data generation. We can create artificial resumes that maintain the skill patterns but balance demographic representation. Step 2, feature selection and proxy variables. Next challenge, choosing the right features. This is where many well-intentioned AI systems go wrong. A resume contains tons of information. Skills, experience, education, previous companies, even writing style and formatting. Some of this is relevant to job performance. Some of it isn't, and some of it is secretly correlated with protected characteristics. These are called proxy variables. For example, certain universities might correlate with socioeconomic status. Gaps in employment history might correlate with gender due to maternity leave. Even zip codes can be proxies for race. Based on this analysis, we remove or transform problematic features. University name might become education level. Location might become willing to relocate. Step 3, algorithmic design choices. Now for the algorithm itself. Your choice here affects fairness as much as your data does. First decision, interpretability versus performance. A simple logistic regression is easy to explain and audit. A deep neural network might be more accurate but harder to understand. For high-stakes decisions like hiring, interpretability usually wins. Let's build a logistic regression with fairness constraints built in. Adversarial debiasing is clever. It trains two networks, one to make hiring predictions, another to guess gender from those predictions. If the second network succeeds, the first network gets penalized. This forces the hiring model to make decisions that don't correlate with gender. There are other approaches too. Fairness constraints directly limit disparate impact. Post-processing techniques adjust outputs to ensure equal outcomes. The key is choosing the right approach for your definition of fairness. Step 4. Built-in monitoring and auditing. Finally, we build monitoring directly into our system. Bias isn't just a training problem. It can emerge over time as populations change. We set up automated alerts when bias metrics exceed thresholds. Monthly reports track performance across groups, and we have a clear process for retraining when problems emerge. Testing and validation. Before deployment, we test everything, not just accuracy, but fairness across different scenarios. We use multiple fairness metrics because they often conflict. Demographic parity, equality of opportunity, calibration. We track them all and make explicit trade-offs. The goal isn't perfect fairness. That's often impossible. It's conscious, documented trade-offs that serve your stakeholders' needs. Try building your own ethical model using this framework. What challenges did you face? What would you add to the process? Let me know in the comments, and I'll see you next time.